So now we have the exercises on solving more of these equations right here. Once again, we should always be looking for where the base is the exact same. Now this one over here is 4 to the x is equal to 16. Now we could figure this out just by thinking about it. 4 to what power is 16? The answer would be 2. So therefore that means that x equals 2. However, let's go ahead and just do what we've been doing, and we'll just convert this one here to a base. So we have 4 to the x is equal to, we got to figure out what power this is, and does it have a common base with this 4? The answer to that would be yes, it is 4 squared. And now I can drop my bases, and it is x equals 2. But then that leads us to one that causes us a little more trouble. At this point, we now have a fraction. But in order to figure this out, we got to actually think about what this number here means. And so I'm going to go ahead and make a little table of the powers that we know. Let's think about this for a minute. Let's start off with an exponent that we do know. What is 3 to the power of 1? It is 3. What is 3 to the power of 2? 3 to the power of 2? In other words, 3 times 3? 9. Then what is 3 cubed? It is 27. One more. What is 3 to the power of 4? Yeah. And if you're in doubt, of course, you may use your calculator. It is 81. And good enough. So let's make a couple of observations real quick. If we look at the number 3 and the number 9, how do I get from the number 3 to 9? Multiply by 3. How do I get from 9 to 27? Multiply by 3. 27 to 81. Multiply by 3. So I get each new power by simply multiplying the last one by 3. If I wanted to get the next one, I would multiply 81 by 3, and it would be 243, which is 3 to the 5th power. However, what this does for me is that it actually allows me to go the other way too, because if I'm multiplying to go this way, what am I doing to go this way? How do I get from 243 to 81? Divide by 3. Then divide this by 3. Divide that by 3. Divide that by 3. And then finally, what's 3 divided by 3? 1. And this right here is to the power of 0. And as we know, any number to the power of 0 is 1, except for 0. So then, we keep on going. What is 1 divided by 3? It's 1 divided by 3, which is what? 1/3. And I'm counting down, so this is 3 to the negative 1. And then, I want to figure out what this is divided by 3. I want to do 1/3 divided by 3. Because of the fact that I'm using a fraction here, I'm going to keep a fraction over here. 3 is 3 over 1. But when I divide by fractions, this is the same as doing 1/3 times the reciprocal of this, which is 1/3. And as we know, we multiply straight across. 1 on top and 9 on the bottom. So therefore, when we divide 1/3 by 3, it is 1 over 9. And that is 3 to the negative 2. But now let's go ahead and make a pattern out of this. Right here we had a 1, but then look over here. Outward, we have 3's. Outward from that, we have 9. What would the next number be? It would be 1 over 27. And what would the next number out be? 1 over 81. I'm going to go ahead and write down the rest of my powers real quick. We got 3 to the negative 2. We got 3 to the negative 3. And 3 to the negative 4. If we think about this, if I really wanted to find out what a negative power does, all I do is I pretend that the power is not there. We get 9. And then when I put the negative, it means to flip it over, to reciprocate. And so therefore 3 to the negative 5, well, let's look at 3 to the 5th. It's 243. So we reciprocate 1 over 243. But the point of all this is that whenever I end up with a problem like this, with 1 over 81, I can recognize that that is 3 to the power of negative 4. And then I'll write down the rest of my equation. Now, they have the same bases. I can go ahead and drop the base. And at that point, we can now solve for x. I'm going to go ahead and get this 2 on the other side. I'll have to subtract it. So I get 2x equals negative 6. Divide both sides by 2. And x is negative 3. There's one more that we will record. Number 5. This one's a little bit weird because our exponent is no longer just an x, but it's x squared. But that's not going to be too much of an issue for us. What we need to do right now, though, we need to find the base for this and what power. So there are a couple of ways we can go about it. First of all, I can multiply 2 over and over again since my base is 2. 2 times 2, that's 2 to the power of 2. To the power of 3. To the power of 4. To the power of 5. To the power of 6. To the power of 7, to the power of 8, and finally to the power of 9. So this right here is 2 to the power of 9. 2 to the x squared is equal to 2 to the power of 9. But the other way that we could check this a little bit faster is if we go to y equals, I want to know the powers of 2, then what is 2 to the power of x? Because this right here is going to give me all the numbers that I could have. We'll go and check our table. 2 to the power of 0 is 1. 2 to the power of 1, and so on. All we got to do now is find out where the number 512 is, and it's right next to the number 9. So that's, so 2 to the power of 9 is 512. X squared equals 9. And so now we have to solve, and we solve by square rooting. But the square root of 9 is, it's 3. However, it's not just positive 3. It's also negative 3. Because negative 3 times negative 3 is 9. And 3 times 3 is also 9. So whenever you are getting rid of a square, you need to remember that it is positive or negative. Now, I can prove this once again by using y equals on the calculator. As with all equations, whenever we are solving, every single time that you are solving, we can always solve by putting the left side of the equation into y1, the right side into y2, and finding the intersection point. So let's do 6 to the power of x squared and 512. Let's graph it. Unfortunately, it's not going to show up here because this number appears at 10, and the rest of the graph is all the way at 512. So I'm going to go to the window, and I'm going to change my y max to about 520. We graph it, we can see. There's my 512 showing up. So now, you'll see that there are in fact 2 intersection points, positive and negative 3. Just to double check that those are the actual numbers though, second trace 5, enter, enter, enter. The intersection is at 3 and 512, positive 3. However, we do have another one over here, second trace 5. You see my cursor, it's right here. I'm going to scroll over to bring my cursor closer to this one. Looks like one a little bit high. There we go. Enter, enter, enter. Intersection is at negative 3. So you will always know based on the number of intersections that there are. And so that is how we solve these more complicated problems when they have a variable in the exponent.